In this video, I will show you how to find the position of C and also the velocity viewed from point A, which is using the reference frame 0. And you can see that B is using the reference frame 1 here, and C is using the reference frame 2. So in order to find the position in C, we first need to find the position in B. We can do that by first using the reference frame 1. So the vector from A to B using reference frame 1 is equal to, so you see that you only follow the x1 here with a length of L1. So it's L1 multiplied by the vector in, multiplied by the unit vector in the x direction for reference frame 1. So in order to find the vector AB with the 0 reference frame, you can see that the difference between this reference frame here and this one is that we just rotate around the z-axis. So the z-axis stayed the same, and these two here moves with q1. So to rotate this vector here, we can just multiply with this matrix. So we will just write rz of q1 multiplied by the vector BA. So as you can see, we rotate counterclockwise, which means that the minus is here and not here. If we were to rotate clockwise, we just transpose this matrix here, and the minus will be here instead. So when we multiply these two matrices together, we will actually just get the first column here, because this is in the x position, the first position here. So we will get L1 cos Q1, L1 sine Q1, and then 0. So now I want to find the vector BC and to later add up AB and BC to get C. So the vector BC is almost the same as the vector AB, just with another reference frame and L2. So the vector BC is equal to L2 multiplied by I2. So in order to get the 0 reference frame again, we need to transform it. But we need to transform it 2 times this time. So first with the ry and then with rz. So this time the ry is actually rotating clockwise, which means that the minus is not here, it's here. And you can see that this is rotating around the y-axis. That is why it looks a little bit different. The vector from the reference point 0 would now be equal to, so first we transpose, rotate around the y-axis, and multiplied by r. B, and then we rotate around the z-axis. We need to do it in this sequence because first we rotate around the y-axis, and then we rotate around the z-axis here. This would therefore be equal to, okay, so we can just multiply with the first one first. So this would be equal to, so we have only in the x direction here, so we just need to multiply L2 by this. So we have L2 multiplied by cos Q2, 0, and L2 multiplied by sine Q2, and then we also need to have the minus in front. So by multiplying this vector by this one, we'd get that cos Q1, and then it's multiplied by L2 cos Q2. That's the first one. Second one is sine Q1 multiplied by L2 and cos Q2. And the last one is on this side multiplied by this one. So it's minus L2 multiplied by sine Q2. So this is the vector RCB. We can now get the vector from A to C by just adding these two here together. So the RCA is equal to, so I just copied this part here to here, and then we can just add this one. So plus L1 cos Q1 plus L2 sine Q1. And that's the position of CA. So this is vector from A to B. So we found the position in C. So now we can try to find the velocity in C. Let's say we first try to find the velocity in B. So with the velocity in B, viewed from reference frame 1, is the cross product of the angular velocity and the vector from A to B. And this is also reference frame 1. Both of these are. So the angular velocity is the Q1 changing over time. So we can add a 1 here. So omega 1 should be equal to Q dot and then multiplied by the axis that it's rotating about. So it should be the K vector here and then 1. So you can use the right-hand rule to find the direction of omega 1. And if you do that, you can see that it's the same direction as Q1 dot. So we don't need any minus sign here. And now see that this R looks like a V, so just rewrite that one. And if you remember, the vector RB is equal to, so view from the reference point 1, is equal to L1 multiplied by I1. If we now multiply these two together, we will get that it is equal to, so we can take out the constants. So Q1 dot is constant and L1 is constant. And this vector cross multiplied by this vector should be equal to the J. And this is the unit vector in the Y direction, this direction here. So you get that by using the right-hand rule. So you multiply this one, this axis, by this axis, and then you get this one. We don't actually need to use these vectors anymore, so I can just remove them. So now I want to find the VB from reference frame 0. And then we can just multiply by this matrix here. So now you can see that we have a J1 instead of I1. So we just multiply Q1 and L1 with this one. The velocity in B would therefore be, so we just put Q1 and L1 in front. And then we get that minus sine Q1. And then we have cos Q1 and then 0. Just like that. In order to find the velocity in point C, we use almost the same method as we used for this one, but it's a little bit more complicated. So now we directly start with the reference frame 0. So the speed should be equal to this one plus the speed over here. So VB 0 omega, and now it's BC. And then plus the velocity of this part here. So this should be omega 2 with the 0 reference frame. And cross multiplied by the vector CB with the 0 reference frame. Now the omega 2 viewed from the reference frame 0 should be equal to this speed plus this angular speed. So if we write that down, so omega 2 is equal to the omega 1 speed viewed from reference frame 1, which is this one. It's just Q1 dot. And then plus, if we want this speed here with the reference frame 0, we also need to rotate it. You multiply by RZ of Q1 multiplied by the speed CB with a reference frame 1. So the angular speed in CB is just this part rotating. So it's just q dot. And it's rotating around the y-axis, which means that this one should be equal to, so yeah, we also need to explain this one. It's just the same as last time. So it's q1 dot, and then multiplied by the k axis. And then we have plus rz q1, and this one is q2 dot multiplied by the y axis. So we have q2 dot multiplied by j in the reference frame 1. Now if we write this one out, we get that we have 0, 0, and then q1 dot. That's the angular speed 1. And then we plus with, so now we multiply this one by this one, which means that we can disregard the first and the third column. So we just look at this one. So we have q2 dot, and then multiplied by minus sine q1. And then we have cos q1, and then 0. And then this should be equal to minus q2 dot sine q1, and then q2 dot cos q1, and then we have the q1 dot here. So this is the angular speed. I just put the angular speed here now. So now we have everything to solve this equation here. So we have the VB0, so I can just add that one. And then we have the cross multiple of the angular speed here. And then cross multiplied by the vector BC. So this should be the equation to solve the speed in point C. So this is going to get really ugly and probably doesn't say much. So I'll just show you what we get. So this part is equal to this. And when you cross multiply these two vectors, you get this one. So it's just, and this expression here is just equal to 1. So we basically get this one. Now, if you add these two vectors together, we'd get this vector. So these are the equations that we ended up with. This point here, the position of the point, is just this vector. The position of this point is this vector. And the speed of this point is this vector here. And the speed of this point is this vector. And everything is viewed from the reference point 0, so this one, and point A.